In today's video, we're going to be looking at how to prove that root 2 is not rational, and to do this, we're going to use proof by contradiction. So in order for us to prove that root 2 is not a rational number or that it's irrational, we're going to use proof by contradiction. So it means we're going to start off assuming the opposite. So we're first of all going to assume that root 2 is a rational number. Okay, so that means that if root 2 is a rational number, it can be written in the form a over b, where a and b are both elements of z, because that's your definition of a rational number, and where b is not equals to 0. And also, because rational numbers are always written in their simplest form, that means that a and b should only have a highest common factor that's equals to 1. And that basically means that a and b in that fraction have nothing else that will divide into them because it's already in its simplest form. So that's kind of the setup. They're the two things that we're going to say straight away. If root 2 is a rational number, which we're assuming it is, it can be written in the form a over b, where a and b are elements of z and b is not equals to 0, and that the highest common factor between them should just be 1. So we're going to look at this equation now, and we're going to just kind of mess around a little bit. So first of all, we're going to get rid of the square root. So we're going to square both sides. So that's going to give me a squared over b squared, and I'll multiply both sides by b squared. So that tells me that 2b squared is equals to a squared. Now, that means that if 2 is being multiplied by b squared, that means that this answer will have to be even, which means that a squared must be even. Okay, so we'll say therefore a squared is even, which therefore means that 2 divides a squared, which therefore means that 2 divides a. Okay, so we know that 2 will divide into a. So then I can say, hence, a then can be written as an even number. So I'm just going to represent a then as 2, and I'm just going to pick a letter to represent a random integer. So let's just pick k. So I'm saying that a can be represented with with 2k I should say, where k is just an integer. So obviously by multiplying that integer by 2, it's showing that a will always be an even number. So what I'm going to do now is I'm going to go back to this section here, and I'm going to substitute in a. So I'm going to substitute 2k in for where a was. Okay, so that's going to give me that 2b squared is equals to 2k all to b squared. So that means 2b squared is equals to 4k squared. I'm going to divide both sides by 2. So that tells me that b squared is equals to 2k squared. Okay, so then that means, again, as k squared is an integer and it's being multiplied by 2, that means, therefore, that b squared is even, which therefore means that b squared is divisible by 2, which therefore means that 2 divides b. So we've just shown that 2 divides into a and 2 divides into b. But remember a few minutes ago we said that if we put a and b on top of each other and we looked at them as a fraction, that we should only have the number 1 between them, i.e. there's no other common factor. But we've just shown that 2 will divide into both of them, which is obviously a problem. Okay, so we've just shown then that so if 2 divides a and 2 divides b, then this contradicts the assumption that we made at the start, that the highest common factor between a and b is 1. So therefore, by proof by contradiction, root 2 is not a rational number. And that is the proof that you will need to learn off by heart in order to show that root 2 is an irrational or root 2 is not a rational number. Thanks for watching today's video. In our video, we used proof by contradiction to show that root 2 is not a rational number.